As we speak, the night sky is undergoing profound changes that will transform its appearance within decades, if not years. Authorities and astronomers around the globe have raised concerns. Prominent figures like Neil deGrasse Tyson have joined forces, announcing that Polaris is on the verge of a significant transformation, and the circumstances surrounding this event are alarming. Polaris's unique position in the night sky has established it as the North Star. Until now, this star has served as a steady point of reference for sky observers, navigators, and astronomers. However, this consistency might soon be disrupted, profoundly impacting both our nocturnal sky and the astronomical measurements we rely on. Join us to understand the severity of this situation and its implications for all. Let's delve into the background of Polaris, which is nearing a crucial stage. Polaris has long been revered as a guiding star, an invaluable beacon for astronomers and navigators throughout history. Its unchanging presence in the heavens has been crucial for celestial navigation. Yet all of this could change abruptly. A recent study presented by the prestigious Royal Astronomical Society in September 2023 has introduced uncertainty about the future of this luminous star. Polaris is on the brink of an explosion that could cause it to vanish permanently from the night sky. Before examining the implications of this discovery, let's explore the star in detail. Polaris, also known as the North Star, holds a significant place in the sky due to its proximity to the celestial North Pole. It is almost directly above the Earth's North Pole, creating the illusion that it remains fixed in the northern sky. The star is located in the constellation Ursa Minor. Polaris is a moderately bright star that stands out as a yellow-white supergiant, significantly larger than our Sun. Although it appears as a single star, it is actually part of a complex triple star system. Within this system, the primary stars are Polaris AA and Polaris EB, which, when observed with the naked eye, appear as one star. Additionally, there is a third companion, Polaris B, orbiting this binary pair. The gravitational interactions among these stars shape their orbits and influence their individual behaviors, directly affecting their brightness and other notable features. Polaris is approximately 323 light-years from Earth, meaning that the light we see from this star today was emitted 323 years ago. This vast distance implies that if Polaris were to explode now, we would not be aware of it until 323 years later. Thus, when we finally observe this event from Earth, more than 3 centuries will have passed since it occurred. Scientific projections, based on current empirical evidence, suggest that Polaris may have already undergone an explosion, but we have not yet received the light from that event. Throughout history, the North Star has played a crucial role across various civilizations and eras. Its value is cultural, symbolic, and vital for navigation. Its steadiness and fixed position near the celestial North Pole have made it an invaluable tool for ancient mariners and explorers. This star has acted as a guiding light, enabling precise orientation and navigation aligned with the Earth's axis of rotation. The North Star holds immense symbolic importance in many cultures. In some communities, it represents the concept of constancy and stability, seen as a guiding pole star that remains unchanged amidst the celestial movements that compose the night sky. Recently, this star has exhibited behavior that deviates from the norm. This unsettling alteration in its pulsation cycle has posed a challenge to astronomers, prompting further investigation into the celestial anomaly. Instead of following the expected pulsation pattern, Polaris has shown unpredictable and erratic cycles of dimming and brightening. This variation has alarmed scientists, who warn that the star might be nearing the end of its life. This change is consistent with the behavior observed in stars as they approach the end of their existence. The gradual increase in Polaris's pulsation times, previously stable in its dimming and brightening cycle, could be due to interactions between the star and its system, despite their appearance as a single entity. Notably, there has been an unusual increase in pulsation duration of approximately 4.5 seconds. Though seemingly minor, this change is of significant importance. Some astronomers have tentatively suggested that the gravitational forces between Polaris and its stars might be causing these fluctuations in the star's atmospheric conditions, directly affecting its pulsation patterns. However, others remain unconvinced and firmly believe that the star is approaching its explosion. This suspicion is based on the striking similarities between the anomalous behavior of Polaris and Betelgeuse. Betelgeuse, another prominent star in the Orion constellation, has shown puzzling variations in its brightness, leading to speculation about a possible imminent explosion. Several experts have warned of the star's inevitable end, highlighting abrupt fluctuations in its brightness and behavior pattern, similar to those of stars nearing the end of their life cycles. NASA has been drawn to the anomalies presented by Betelgeuse. The agency has expressed significant concern about the possibility of Betelgeuse exploding, in contrast to the irregularities observed in Polaris. Although NASA has shown strong interest and vigilance toward Betelgeuse's unusual behavior, it has not made an official statement of similar concern regarding Polaris. Stars undergo extensive journeys through different stages in their evolutionary cycles. Initially, these stars have relatively low temperatures and brightness. They then advance to the main sequence phase, characterized by nuclear fusion, where they remain stable for billions of years. Ultimately, as their hydrogen fuel is depleted, they enter the red giant phase, marked by a rapid increase in temperature and brightness. This phase sees a dramatic rise in energy output before culminating in a catastrophic explosion. If Polaris were to experience a supernova, we would surely witness a spectacular event in our sky. The star would become incredibly bright, surpassing even the moon's brilliance, and becoming one of the most luminous objects in the night sky. This dazzling display could last for days, weeks, or even months. The star's visual appearance would undergo drastic changes. It would transform into a brilliant point of light or a temporary bright object, potentially displaying different colors before fading. This visual transformation could momentarily alter our familiar view of the constellations Ursa Major or Ursa Minor, as Polaris is part of these stellar groupings. As for our safety, we would be completely secure. Given the size and distance of Polaris, it is unlikely that the Earth would be affected even in the event of a stellar explosion. Visually, while a Polaris supernova may not be as remarkable as Betelgeuse, it could still be visible to the naked eye for an extended period and outshine nearby bright stars. The potential supernova of Polaris would mark a significant event in astronomical history, offering scientists a rare opportunity to observe and study the dynamics of a star's explosive end up close. Despite its current stability, Polaris's irregular pulsation patterns and the gravitational interactions within its triple star system suggest an impending change. Astronomers continue to monitor its behavior closely, seeking clues that could illuminate when and how this celestial transformation will occur. The unique position of Polaris as the North Star makes its future even more impactful, potentially altering millennia-old navigational traditions and cultural symbolism across societies. Polaris, scientifically known as Alpha Ursae Minoris, has been a steadfast fixture in the night sky for centuries. It is almost directly above the Earth's North Pole, making it a crucial celestial reference point for navigators and astronomers alike. The star's proximity to the celestial pole creates the appearance of remaining stationary as the Earth rotates, providing a consistent marker in the northern sky. This stability has earned Polaris a prominent place in human history and culture, where it has inspired myths, legends, and scientific inquiry, symbolizing the eternal quest for knowledge and understanding of the cosmos. The scientific interest in Polaris extends beyond its navigational utility. As a star nearing the end of its life cycle, Polaris provides a unique opportunity to study stellar evolution and the processes governing the birth and death of stars. It belongs to the class of Cepheid variable stars, known for their periodic pulsations in brightness. These pulsations are linked to changes in the star's size and temperature, offering astronomers valuable insights into the internal dynamics of stars. Recent observations and studies have revealed unexpected behavior in Polaris's pulsation cycle. Instead of following its usual pattern of regular dimming and brightening, Polaris has shown irregular fluctuations in brightness. This variability suggests underlying changes within the star, possibly indicating instability in its core processes. While such fluctuations are not uncommon in variable stars, the implications for Polaris, given its status as the North Star, are significant. A pivotal moment in the study of Polaris came with a study presented by the Royal Astronomical Society in 2023, which raised substantial questions about the star's future. The study suggested that Polaris may be nearing the end of its life cycle and could potentially undergo a supernova explosion in the near future. This revelation sparked intense scrutiny and renewed interest in the star's behavior, prompting astronomers worldwide to intensify their observations and analyses. Understanding the potential supernova of Polaris involves examining the intricate dynamics of its stellar system. Polaris is not a solitary star but part of a triple star system comprising Polaris AA, Polaris EB, and Polaris B. Polaris AA and EB form a binary pair orbiting closely, while Polaris B orbits this binary pair at a greater distance. The gravitational interactions among these stars influence their orbits and behaviors, contributing to the overall stability or instability of the system. The complex nature of Polaris's triple star system adds layers of complexity to predicting its future. While Polaris AA and EB are the primary contributors to Polaris's observed brightness, the presence of Polaris B introduces additional gravitational influences that could perturb the system. Astronomers hypothesize that these interactions may be responsible for the recent irregularities observed in Polaris's pulsation patterns, indicating potential changes in the star's internal structure. Theoretical models of stellar evolution suggest that stars like Polaris undergo significant transformations as they approach the end of their lives. Initially, Polaris would have been a relatively cool star, gradually transitioning to the main sequence phase, where nuclear fusion in its core sustained its brightness and stability for millions of years. However, as Polaris exhausts its hydrogen fuel, it enters the later stages of stellar evolution, characterized by dramatic increases in temperature and brightness. The red giant phase marks a critical stage in a star's evolution, where it expands to several times its original size, becoming thousands of times more luminous than in its earlier stages. For Polaris, this phase would signify a notable increase in its energy output, potentially leading to observable changes in its appearance from Earth. The star's increased luminosity could make it appear brighter and more prominent in the night sky, altering its role as a navigational beacon and cultural symbol. Beyond the red giant phase lies the eventual fate of stars like Polaris, the possibility of a supernova explosion. Supernovae are among the most energetic events in the universe, releasing vast amounts of energy and matter into space. When a massive star exhausts its nuclear fuel and can no longer sustain the fusion reactions that support it, gravitational collapse triggers a catastrophic explosion. This explosion, visible across vast distances, can temporarily outshine entire galaxies and leave behind remnants such as neutron stars or black holes. If Polaris were to undergo a supernova, astronomers predict that it would become one of the brightest objects in the night sky, potentially rivaling the brilliance of the moon. The sudden increase in luminosity would be accompanied by dramatic changes in its visual appearance, transforming Polaris into a dazzling point of light or a temporary bright object visible to the naked eye. Such an event would not only captivate astronomers but also provide valuable data on the final stages of stellar evolution. The study of Polaris's potential supernova is not merely academic but holds practical implications for Earth and its inhabitants. Despite its celestial significance, the explosion of Polaris would pose no direct threat to our planet due to its immense distance from Earth, approximately 323 light-years away. Any effects from its supernova would be limited to the observable light and radiation emitted during the event. From a scientific perspective, the supernova of Polaris would provide a unique opportunity to study the physics of supernovae and their impact on surrounding space. Astronomers would observe the evolution of the explosion, from the initial burst of light to the formation of nebulae and remnants that continue to expand across the cosmos. These observations could yield insights into the origins of elements essential for life, such as carbon, oxygen, and nitrogen, which are forged in the intense heat and pressure of supernovae. Moreover, the supernova of Polaris would have broader implications for our understanding of the universe's structure and evolution. By studying how stars like Polaris end their lives, astronomers can refine models of stellar evolution and improve predictions of how galaxies, including our own Milky Way, evolve over billions of years. The remnants left behind by supernovae play crucial roles in the formation of new stars and planetary systems, shaping the cosmic landscape we observe today. The cultural and historical significance of Polaris further underscores its importance in the study of astronomy and human civilization. For centuries, Polaris has guided travelers across oceans and deserts, serving as a reliable reference point for navigation and exploration. Its constancy in the night sky has inspired myths, legends, and scientific inquiry, symbolizing the enduring quest for knowledge and understanding of the cosmos. In ancient times, Polaris held spiritual and navigational significance for civilizations around the world. In Norse mythology, Polaris was associated with the god Odin, who was believed to guide souls to the afterlife. In Chinese astronomy, Polaris was revered as the central star around which all other stars revolved, symbolizing order and stability in the heavens. Across cultures, Polaris has been a symbol of guidance, leadership, and the unchanging principles that govern the universe. The potential loss of Polaris as a visible star in the night sky would mark the end of an era in astronomy and cultural heritage. Its absence would not only affect navigational practices but also alter our perception of the cosmos and our place within it. The constellations Ursa Major and Ursa Minor, with which Polaris is closely associated, would lose their guiding star, reshaping the narratives and interpretations that have persisted for centuries. While the future of Polaris remains uncertain, ongoing observations and research efforts are aimed at unraveling the mysteries surrounding its behavior and predicting its fate. Advanced telescopes and observational techniques enable astronomers to monitor Polaris's brightness, spectral characteristics, and pulsation patterns with unprecedented detail. These observations provide valuable data points for theoretical models and simulations that simulate the conditions within Polaris and predict its future evolution. The study of variable stars like Polaris is part of a broader effort to understand the diversity of stellar phenomena and their impact on the universe. Variable stars exhibit changes in brightness over time, offering insights into the physical processes occurring within stars and their evolutionary paths. By studying these changes, astronomers can classify variable stars into different categories based on their behavior and identify underlying mechanisms driving their variability. Polaris's status as a Cepheid variable star places it among a class of stars used to measure distances in the universe. The relationship between a Cepheid star's period of pulsation and its intrinsic luminosity allows astronomers to calculate its distance from Earth with high precision. This method, known as the cosmic distance ladder, forms the basis for measuring distances to galaxies, clusters of stars, and other celestial objects across vast cosmic scales. The accuracy of distance measurements derived from Cepheid variables like Polaris has far-reaching implications for our understanding of the size, age, and expansion rate of the universe. By calibrating the cosmic distance ladder with precise measurements of nearby variable stars, astronomers can refine their estimates of the Hubble constant, a key parameter that describes the rate at which the universe is expanding. These measurements contribute to cosmological models that trace the evolution of the universe from its early beginnings to its current state. In conclusion, Polaris occupies a unique position in both the night sky and human history, embodying the enduring quest for knowledge and understanding of the cosmos. As a Cepheid variable star nearing the end of its life cycle, Polaris offers scientists a window into the processes that shape the birth, life, and death of stars. The potential supernova of Polaris represents not only a scientific milestone but also a cultural and historical turning point, reminding us of our place within the vast and ever-changing universe.